Sean.
Hey everyone, welcome to Grab Time with Sara and Sean. I'm Sara.
And I'm Sean. Sara and I make interactions, games, and animations, and we do it all using math in the Desmos graphing calculator.
And last time we started talking about animation timers, and today we're going to talk some more about animation timers and see what other cool things we can do. And I'm really excited to jump right into it.
Yeah, and I will say, if you're watching this one and you haven't watched the last one, the introduction to animation timers, if you want to know how this works, it might be a good idea to look back at that episode. We'll link it in the comments, but otherwise, enjoy what we have for you today.
All right, here we are. Here's our animation function that Sean talked about last week. We're going to use that. I'm also just going to go ahead and start by putting a time variable in our graph because we're going to be using time today to make our animation. Last time, we also had a nice little blob. We're going to bring back a blob, but this time it's going to be orange. Here we go. We're going to... So fun. We're going to start with our little blob here. And I don't really think we need the grid. Should I just turn it off?
Yeah. I didn't even have to say it.
Goodbye. And you know what? I'll even just start P blob. I have my point and I'm going to do stuff to this point. I'm going to center my image at this point. And now we have a nice base for what we're working with. Okay, Sean, what should we do? Where should we start?
I feel like we should make this blob do a little jump. It's a little bit harder than what we did last time.
Let's do it. Okay, so I'm imagining maybe we want the blob to do a little something like this.
Yeah, and last time we kind of thought about like the X movement and the Y movement differently. So like how it's moving horizontally and how it's moving vertically.
Yeah, totally. All right. So make my animation timer that's going to control my jump. And let's say we want the jump to take like a second. I don't know. Maybe that will feel wrong. We can address it later, which is a really cool thing about animation timers. The first entry of my animation timer is the time that my jump's going to start. So maybe I want to start at 0. The second is how long I want it to take. So maybe I want this to take 1 second to do a full jump. Time, my animation variable. This is a fine starting place for our blob. Maybe I want to add some X direction. I'll just pick 4 units. Maybe I add 0. This is what it looks like if I add 4 units in the X direction, or 5 or 6. Sure, 6 feels good. And I don't want to add it all at once. I want to add that over the course of my jump. So I can take my animation timer and I can multiply it to this stick.
Nice.
And I'm going to put a 4 as my end time because I think there's something in the calculator where 4 seconds on a timer makes it like equivalent to 1 second. Anyways, that's what I have going.
Yeah. When you play that, it should actually go in real time or maybe exactly.
Oh, and I don't want it to go back and forth. So I'm going to have it play once in one direction. Okay.
So there's 2 pieces to this jump. There's like how it moves left and right and how it moves up and down. And
yes.
And when we jump to the right, it's just moving to the right at kind of a consistent speed.
Yeah. And you know what? When I think about jumping up and down, at 0, I want it to start like on the ground. I want to go up in a curve, and then at the end of my animation timers, which go from 0 to 1. So like at 1, I want it to be back on the ground. So I'm actually going to try and create a function that helps me start and end at 0 and goes up and down in between 0 and 1.
Yeah, right.
Yeah.
So usually our animation timers go like from 0% to 100%, and that's just going to happen like in a straight line. But what you're actually saying is we want it to go from 0 to 100% and back to 0% again.
Yes. Yeah, we can do that. One way I like to do that, like I think about, like I'm describing kind of an upside down U shape. So That's a parabola or a quadratic. And if I wanted to go through 0 and 1, I can make those my like x-intercepts. I know it's a quadratic, so I'm actually going to start building this function that I'm going to call quad. And this goes through 0. And if I multiply it by x minus 1, it's also going through 0. Sorry, it's going through 1, 0. But this is not the direction that I want it to be in. I want it to look more like a jump. And so if I multiply it by negative out front, I start to have my quad looking type thing, or like something sort of like a jump.
Yeah, and if we just multiply by negative, that's just gonna like flip our entire graph over.
Yeah. Sean, how do you want to change this function? I heard you say a few other things.
Yeah, so I was kind of thinking, so this starts at 0.
Mm-hmm.
When it's 0, it's 0, and when the x is 1, it's 0.
Lots of numbers.
Okay, that's good, but it doesn't really go to 100%. Only goes to 25%, like 0.25.
Yeah.
So we don't want to stretch this, and we want it to be like 4 times as much, right? Like it's at 0.25, so 4 times as much. Put a 4 in there.
Cool.
Okay, cool.
Okay, we're gonna use this to help us. Perfect. Located the blob. Amazing. Why did I do this? I did all of this because I want to change the y value. I wanted to go up and then back down. How much do I want it to go up and back down? 5? Maybe okay. Yeah, that looks good.
It's a high jump.
Here's my blob at 0. Here's my blob at 5. And I'm going to do two things. I'm going to use my quad function. So at 0, at time 0, we're going to be at 0. Halfway through, it's going to get all the way up to 5. And then at the very end, we're going to be at 0 again. And my input here is actually going to be my animation timer. So I'm changing what's happening over the course of 0 and 1. Instead of just growing, it's like going to grow and then decrease.
Yeah, so basically it's just going to take the animation timer you had, keep the timing the same, but just make it go up and down like we saw in that graph earlier. It's going to go up and down.
All right, let's see what happens. Oh my gosh. Cute.
Yeah, and this like might be a lot to take in at once. Highly recommend like check out the graph itself, play around with the different numbers, see how it works. If you don't totally understand everything we talked about or how it's working, it's really okay. We'll provide you that link so you can just mess around with it yourself, change some of the numbers, and quad is just what's making it go up and come back down and feel like an actual jump.
So another pretty cool thing that we can do with animation timers is we can make multiple things happen at once. If we use a list, then we can do some pretty cool things kind of condensed. Let's start with making 3 blobs. And like eventually with like only a few adjustments, we could make like 50 blobs, which is kind of a benefit, but we'll start with way fewer than that. In my current P blob, we have a starting place. I could have them all start at the same spot, but then like they'd all be overlapping. So maybe we can have 3 different starting places. How does that sound?
Great.
I'm going to call this like capital P blobs. And we're we'll do some parallel reasoning. We'll have this line to go off of and we'll create something similar right below it.
Love it.
I'm going to change these X values because maybe we want them all next to each other. That feels kind of reasonable to do.
That one, the X value's -5, right? And if I wanted to have 3 blobs, I'd probably want them to be like -5, -3, and -1. But how do I write that in the calculator? Like how do I make the calculator know that there are 3 numbers that I want to use?
There's a few ways you can do that. I have these square brackets, and these square brackets are telling me that there's a list. So I'm going to put more than one number in there. So you said -5, -3, and -1. This is a list. I'm going to make this all of the X values, put a comma, and this is kind of a complicated Y value, so I'll just make it 2. -2. Now you can see immediately the calculator knows we have -5, -2, -3, -2, and -1, -2. All right, we have all three of those. Although it's looking like they might be close together if they were all there. Now we want to add stuff. We want to add 6 in the X direction and 5 of this quad thing in the Y direction. And I'm going to go ahead and see what happens when I change my center. What do you think is going to happen, Sean?
Okay, so all the brackets and the commas and everything, that just means there's 3 spots and we can see them, the red points.
Mhm.
So it should just be that there's 3 blobs. Like if you say, I want the center to be these 3 points, there's not going to be 3 blobs in those spots.
And if I leave this exactly the same, what do you think is going to happen?
Okay, so the positions are in a list and each of them is going to jump, but all the jumping stuff isn't in a list. So they're going to jump all at the same time.
Okay, yep. All of our blobs jumped simultaneously in unison.
I feel like I want them to jump one at a time though.
I feel like I agree with you. One way that we can make them jump at different times is by starting their jumps at different times. Like if we just stagger their start times a little bit, it'll kind of look like not this cascading effect.
So we're gonna find where we have like what number on this whole graph is like when it starts, and we're just gonna make that 3 separate numbers.
Yep. So I'm gonna make another list of start times. In my like original A jump, I'm starting at 0. I'll make my first one start at 0. Maybe the next one could start like a half second later. So maybe 0.5.
They might crash though. I'm not sure. We'll see.
They might. And the last one maybe as another half second later. So I'm going to write a new timer kind of similar to this. And I'm going to use capitals. Capitals can help me remember that I'm referring to a list. So I'll do that a lot.
Yeah, we tend to just name all our lists in capitals. It's not a thing you have to do, but sometimes if you don't know that something's a list, it can create really big problems. We're not going to get into it, but like just to avoid that and to be able to tell at a glance if something's a list, we just often name them with capital letters.
Yep. I could have taken this list of start times and put it directly into my animate function, but I like to separate it out sometimes to help me organize my thinking. All right, I have my start times and my duration. I think all of them can jump for 1 second, and that's fine. And then my time variable. Now I have 3 animation timers going here. Yeah, so I'll replace this with my capital. And should we give it a go?
Yeah, I'm excited.
Okay, me too.
That's perfect. I thought we were gonna have to do some tweaks, but it's like they're playing like leapfrog. They do crash. They do crash though.
Only a little.
Technically, yeah.
Okay, Sean, how come part of me was like, oh, like maybe this one I want to jump first? Like, how come this one in the very back jumped first?
I think it has to do, like all of your lists are going to match up. So the first position in your list is -5, which is the furthest to the left one.
Mm-hmm.
And the first timer in A jump was 0. So those are gonna match up, and that's gonna be the one that starts.
So what if I wanted to start with this one instead?
So there's a few things you could do, but the one that makes most sense to me is just change the starting position of each of them. So just switch the order of that position list. It would also work to switch the position of the time they start jumping. That's actually pretty fun too. I thought I was gonna like leapfrog better, but that one's pretty nice.
Adorable.
Well, thanks for joining us, everybody. We had a great time sharing this with you. We'll put the link to this in the comments so you can check it out. If you have any questions about how to graph or animate, let us know. To leave you with some words of wisdom, I'm gonna channel my coworker Ian McMeeking. Stay hydrated. You can't graph if you're dried out. Those are your words of wisdom for the day.
Thanks for coming. Thanks for joining us in graphing today, and we will see you next time.
See you next time.
Sara and Sean.